Today you're going to review how to graph quadratic equations in different forms, and we're going to start off with standard form. So in your notes, please write down what standard form looks like. So this is what standard form looks like. And what does this form tell us? Well, A tells us a few things. So I'm just going to draw little arrows down here. A tells us two things. It tells us whether our parabola opens up or it opens down. If A is positive, it opens up, and if A is negative, it opens down, or reflects across the x-axis, in other words. A also tells us if our parabola's shape is going to stretch or compress. If A is greater than 1, it stretches, and I'll show you an example of what that looks like in just a second. And if A is greater than 0 but less than 1, then it compresses. Now here's just a very basic picture of a parent function, quadratic function, okay? And if A was greater than 0, let me grab a colored pen here. If A was greater than 1, an example of it stretching, if this value was like 2, 3, or 4, then our parabola would stretch, which means it would get skinnier. If A was between 0 and 1, it would compress or flatten out. The C value tells us what the y-intercept is. The B value helps us find the x-coordinate of the vertex, which is also the equation, it's the numerical value for the equation of the line of symmetry. Everything you go over today, you've already learned, but it may have been since 8th or 9th grade, and it's probably a great time to review this. So the equation here to find the line of symmetry, the x-coordinate of the vertex, is x equals negative b over 2a. All right, so we are going to learn once again how do we graph a quadratic function that's in standard form without using technology. We will use technology on our next example when finding the x-intercepts, but everything else we can do without it. So let's write this equation down. Y equals x squared plus 4x plus 3. So the first thing we're going to do, step number 1, is going to be, let's decide, does this parabola open up or down? And it's all based on that A value. So the A is 1, B is 4, and C is 3. Because A is positive, my parabola opens up. So I'm just going to draw a really simple picture of a parabola opening upward. Step 2, I'm going to do line of symmetry. Line of symmetry, just being a little lazy here, but line of symmetry. And I need to use the equation every time, x equals negative b over 2a when working with quadratic functions. So substituting in a b value and an a value, I end up with x equals negative 4 over 2, so x equals negative 2. This is not only the equation of the line of symmetry, it also represents the x-coordinate of the vertex. So I know the vertex has a value of negative 2, an x value of negative 2. Now how do you find the y value? To find the y value, you take this x-coordinate and you plug it into the original problem wherever you see an x value. So I'm going to do the math over here. Some of you may do it mentally. Negative 2 squared plus 4 times negative 2 plus 3. Negative 2 squared is 4 minus 8 plus 3. negative 4 plus 3, y equals negative 1. Step number 4, I'm going to identify the y-intercept. Remember, your y-intercept, as we mentioned above, in standard form is this constant at the very end. So the coordinates of my y-intercept would be 0, 3. And the last thing I'm going to do is going to be step 5, which would be the x-intercepts. You can always, always, always use the quadratic formula to find the x-intercepts. And we're going to talk more about x-intercepts after we get done practicing graphing in standard form. But you can always use quadratic formula. But a faster way that sometimes works and sometimes doesn't is using factoring. So we're going to test right now, can I factor this? So x squared plus 4x plus 3. Remember, when you're finding the x-intercept, your y value is 0. So is it possible to find two numbers that multiply to equal 3 and combine to give you 4? Is there a combination of two numbers that multiply to equal 3 and combine to give you 4? And there is. What are those two values? Plus 3 and plus 1. So here's why this is so quick. In this form, I get to put a box around these numerical values. And whatever is directly opposite of that are going to be the x-intercept. So x equals negative 3, one answer. X equals negative 1, second answer. Okay, we're ready to graph. So I'm going to go back to step 1. Remember, I know that it's going to be opening up. Step 2 says I'm going to graph the line of symmetry x equals negative 2. Make sure it is a dotted line. Step 3 says let's graph the vertex, negative 2, negative 1. Step 4 says we're going to graph the y-intercept, so 0, 3. And now I want all eyes up here. I'm going to show you how we get to cheat. All eyes up here, please. We've already talked that parabolas are symmetrical, and they're actually cut in half by the line of symmetry, or axis symmetry. This is exactly 2 units away. This y-intercept is 2 units away in this problem from the axis symmetry. So I get to go 2 units to the left and make a dot. I'm going to graph the 2 x-intercepts, and then remember to add arrows as the parabola moves up to the left and up to the right. Do me a favor right now. Can you please do red cup or green cup based on your understanding? Red cup or green cup? Totally fine to be a red cup. What's your level of understanding? Okay, got it. Here's your next problem. And I'm going to have you write it down, and then we're going to talk as a group. I'm going to pause this after we write it down. Please write down y equals x squared minus 2x minus 8. I'm going to press pause in the video, and I'd like you to turn to your elbow partner, and I'd like you to express the 1 or 2 things about the last problem that seemed to confuse you and see if they can help. We're going to do the same procedures we used in the last example with this quadratic function, and then we're also going to analyze it with like the domain, the range, the end behavior, increasing and decreasing intervals, things we've already learned that we can apply to this problem. So we're going to start again. Step number 1. Step number 1 is, does this open up or down? And this particular quadratic function opens up because a is positive. Also, just to let you know, it neither compresses or stretches because the a value is 1. Step number 2, we're going to come up with the equation of the line of symmetry. So x equals negative b over 2a. Two negatives make a positive, and 2 divided by 2 would be x equals 1. Now that serves a couple purposes. Not only is it just the equation of the axis of symmetry, it also is the x-coordinate of the vertex. To identify the y-coordinate of the vertex, I'm going to take this value for x and I'm substituting it wherever I see an x in the original equation. If you see me make an arithmetic mistake, please let me know. Step number 4 is to identify what the y-intercept for this problem would be. I'm going to write it as an ordered pair. Remember, the y-intercept can be easily found in standard form by looking at the constant value, 0, -8. All right, step 5 is the most difficult for most students, and it's how do we identify the x-intercepts. Remember, quadratic function, using the quadratic formula will always work, but sometimes we can also use factoring to solve, not always. So let's check. When we find an x-intercept, y is equal to 0. Do we know two numbers that multiply to equal -8 and combine to equal -2? 4 and -2?
Wait, no.
Close, very close. -4 and 2. Okay, let's write that down. -4 and +2. Now we're able to box in those numerical values. And just the opposite of -4 would be x equals +4 and x equals -2. These are the two x-intercepts. Written as an ordered pair would be 4, 0 and -2, 0. Okay, it's time to graph this. Let's come back up here. I'm going to do the line of symmetry, so I'm going to go to where x equals 1 and make a dotted vertical line cutting through the x-axis at 1. Then I'm going to go graph the vertex 1, -9. I'm going to graph the y-intercept of 0, -8. And then knowing that this parabola is symmetrical, I know that if this point on the parabola is 1 unit from the line of symmetry, I can go 1 unit in the opposite direction, and I'll also find a point on the parabola. Graph the x-intercepts. To analyze this graph, we can see that from left to right, it decreases until it hits the turning point, also known as the vertex, and then it begins to increase. So it decreases on the interval, coming from the far left, -infinity, and it decreases to an x value of 1. It increases after 1 from 1 to +infinity. What would be the end behavior? Remember, for parabolas, your y's will be the same. Your x's always for every graph we analyze look like this. This says as I go to the far left, what's happening? As I go to the far right, what's happening? In both cases, the graph is heading up. This parabola is going to open upwards because A is positive. The line of symmetry. So -4 over 2 times 1, x equals 4 over 2, which is 2. Step 3 is going to be the vertex. This coordinate is also the x-coordinate of the vertex, and I can plug it in for the x values in the original equation to solve for y. 2 squared is 4. Negative 4 times 2 is negative 8 minus 5. Once again, parabola opens upward. The equation for the axis of symmetry or line of symmetry, and this is your vertex. Your y-intercept comes from the c value when written in standard form. And your x-intercepts, you can always rely on the quadratic formula to find the x-intercepts, but not everything is factorable, so that's why we do need to use the quadratic formula sometimes. I'm going to see if I can factor it here. So I'm going to set y equal to 0. Is it possible to find two numbers that multiply to equal negative 5 and combine to give you negative 4? It is possible. X is negative 5 and positive 1. And then if I box these in, I'm able to quickly identify the x-intercepts as the opposite values. So 5 and negative 1. Written as an ordered pair is 5, 0 and negative 1, 0. Okay, to graph this. So I'm going to go to positive 2. Then I'm going to graph the vertex of 2, negative 9. Then I'm going to graph the y-intercepts of 0, negative 5. And because of symmetry, I can go 2 in the opposite direction. And I'm going to graph the ordered pairs. So I can see the end behavior similar to our last few problems. In both cases, when I go to the far left and the far right, the function is heading up. Also, I can see from left to right, as I analyze this, it's decreasing. Turning point is neutral, and then it turns to increasing. So it increases from 2 to positive infinity, and it decreases from negative infinity to 2. Okay, number 1 is to graph each quadratic function without using a graphing calculator, and then we will complete each portion. So I'm going to start off with step 1. I know A is negative 2, B is negative 4, and C is 12. Step 1 would say, does my parabola open upwards or downwards? Because A is negative, it opens down. Keep in mind, not only does it open down, it's going to be stretched by a factor of 2, which means it's going to be a skinnier parabola than what we've been working with. So step 1 is done. Now on to step 2. Step 2 is going to be the line of symmetry. So x equals negative b all over 2a. The two negatives make a positive on top. And I'm left with x equals 4 over negative 4, or x is equal to negative 1. That is the equation of the line of symmetry, also known as the axis symmetry. So I'm going to come down here and write x equals negative 1. And actually, I'm going to come off to the side, over to the graph, and I'm going to graph that right away. I unintentionally started graphing it at 2, but it should be crossing the x-axis at negative 1. Okay, the third step is to identify the vertex. Now, this value will be the x value of the vertex. And to find out the y value, we're going to substitute negative 1 in wherever we see an x in the original function. And I would like you to not jump ahead, but to talk about this really quick. In previous classes, I learned that some students want to distribute a negative 2. Don't do that. PEMDAS says do exponents before you multiply. So negative 1 squared is simply 1. And now we can multiply and combine things. Negative 2 times 1, negative 4 times negative 1. The vertex is negative 114. I know this goes off the graph. We do want to be as accurate as possible here. So here's 10, 11, 12, 13, 14. The fourth step is going to be to identify the y-intercept. The y-intercept, I can see it's 12, so 0, 12. And then I'm going to graph that. So 0, 12. Remember, this is symmetrical, so I'm 1 away from the axis of symmetry. I go 1 in the opposite direction. Give me 1 second. All right, now we're going to do the x-intercept. So we want to see, can I factor this? So I'm going to first start by factoring out a negative 2. It'll be easier for me to factor this. If it's not factorable, we have to rely on the quadratic formula. So I'm going to factor out a negative 2. And then I'm going to make sure by distributing, did I factor out the negative 2 correctly? Okay, that's correct. Negative 4 and positive 12. All right. So this portion, this trinomial, is this factorable? Do you know two numbers that multiplied to equal negative 6 and combined to give you 2? Not factorable, right? We have to use quadratic formula, and that's what makes this a little bit messier. It's very important you know how to do this because we do need to give exact values. We'll estimate them on the graph, but we need to get exact values as ordered pairs for the x-intercept. Okay, here we go. A equals negative 2. B is negative 4 as we have up above, and C is 12. This is a formula you do have to have memorized. So negative B, which means we change the sign of the B, plus or minus B squared minus 4AC all over 2A. Grab your calculators, please. We are going to find out the discriminant. We are going to look at the discriminant right now. So, plugging this in with me, we're going to start with a parenthesis, negative 4 squared. Subtract 4, parenthesis, negative 2, and parenthesis, 12, and parenthesis. This is the discriminant. We are going to review tomorrow, or because of our weird testing schedule on Friday, that the discriminant is a way for us to tell what type of x-intercepts we have, or solutions. Are they real, like an x-intercept, or are they complex? So the answer is 112. All right, so now I do 4 plus or minus the square root of 112 over negative 4. Now I need to check and see, is 112, am I able to simplify it? You don't have to write this down. 1, 4, 9, 16, 25, 36, 49, 60, 40, 100, 121. Here is where 112 falls. So I'm going to do this the slow way in case you're confused how to simplify a radical. So this is a square root, so I'm looking at perfect squares. I'm typing in 112, and I'm going to, bless you, I'm going to start dividing by everything less than it. I'm looking for a whole number. Nope. Try the next one. Nope. And this tells me, can I simplify this? And you're going to keep going until you see that the first number that it simplifies with is 16. So I know 16 times 7 is 112. What does that do for us? So I'm going to write down 4 plus or minus square root of 16 times the square root of 7. The square root of 16, I'm going to replace that with a 4. And now we can continue to simplify if this number in the denominator is both divisible by both real portions. So can 4 divide into 4 and 4? Yeah, it can. So here we go. 4 divided by negative 4. So 4 over negative 4 plus or minus 4 over negative 4 with the square root of 7. 4 divided by negative 4 is negative 1. 4 divided by 4 is negative 1. And now we're ready to take this and write down two ordered pairs that represent the exact x-intercepts. So I'm going to come over here. One is negative 1 plus negative 1 squared to 7, comma 0. And then negative 1 minus negative 1 squared to 7, comma 0. For all of us, we may be like, okay, I got the answer, but I really don't know what type of number does that represent. So we're going to grab the calculator and we're going to estimate it so that we can graph it. So grab your graphing calculator. Let's do the first one. Negative 1 plus negative 1 square root of 7. Okay, I don't want this answer as an exact x-intercept. This is only going to be right here. This is only going to be, oh, I do not want to write on the screen. This is only going to be used to estimate. So negative 3.6, let's graph negative 3.6 right now. Negative 3.6. 1, 2, 3, 4, negative 3.6. Now I'm going to do the same thing. Negative 1 subtract negative 1 square root of 7, and an estimation is 1.6. Domain, there's no limit how far it goes to the left or to the right. Range, we always start with the low part. There's no limit how low it goes. It does go as high as a y value of 14, and it's included.